In this video, we are going to discuss about operations on sets. Okay, operation on sets. So first, we are going to discuss about union of sets. Okay, union of sets. Suppose we have two sets, union of two sets. Suppose union of two sets A and B is given by A union B, the set of X such that either X belongs to A or X belongs to B. Okay, so X must be an element of either set A or B. Okay, so now for example, suppose set A contains 1, 2, 3, 4 and B contains 3, 4, 5, 6, 7. Okay, then A union B should be containing 1, 2, 3, 4, 5, 6, 7. Okay, all the elements in A and B must be in A union B. Okay, so its element of A and B must be either element of set A or set B, or it may be in both of them. Okay, but don't repeat the same element. Okay, suppose 4 is in set A and B as well, but we have to write here only once. Okay, so that is union. If suppose A is non-empty set and B is an empty set or null set, okay, then, or you can say B is equal to 5. Okay, in this case A union B is equal to A, because A is empty set or null set, so that's why union of these two sets must give A. So let me explain. A contains suppose 1, 2, 3. As B is null set, so there should be no element. Okay, then if you find the union of these two sets, then you can take the elements of A only, 1, 2, 3. As there is no element, so that's why this is equal to set A. Similarly, if set A is empty set and set B is something else, suppose 1, 2, 3. Okay, in this case A union B must be equal to set B, and if both A and B equal to 5, then A union B is also equal to 5. Okay, so now next, intersection of two sets. Okay, now we are going to discuss about intersection of two sets. Okay, so how to find intersection? Suppose we have two sets A and B. Okay, A contains 1, 2, 3, then B contains 2, 4, 5. Okay, then A intersection B is a set of common elements of these two sets. So what are the common elements here? 2 and only 2. So this is intersection. Okay, so we can write intersection of two sets, intersection of two sets A and B is given by A intersection B equal to a set of X such that X belongs to A and X belongs to B. So X must be present in both A and B. Now you see, in this case, if set A is null set, A is equal to 5, and set B is suppose 1, 2, 3, okay, then that means B is non-empty set. Okay, then A union B is 5 because there is no common elements. Okay, similarly, if A is non-empty set, maybe let it be suppose 1, 2, 3. Okay, set of 1, 2, 3, and B is 5. In that case also, A intersection B gives 5. Okay, now you see disjoint sets. Now we are going to discuss about disjoint set. Disjoint sets. Okay, now you see, suppose we have two sets. A is equal to a set of 1, 2, 3. B, set B contains suppose 4, 5. Okay, here you see A intersection B must be equal to 5 because there is no common elements in these two sets. In this case, A and B are disjoint. Okay, disjoint. Okay, so what is the definition of disjoint sets? If A union B is equal to 5, then we can say A and B are disjoint. So hope you have understood this topic. Now let us discuss about difference of two sets. Okay, difference of two sets. Okay, suppose we have two sets. Okay, A, set A contains 1, 2, 3, 4, and B contains 2 and 3. Then A difference B is equal to what? It is a set where these common elements are not present. Okay, only elements of A which are not in set B should be present in this result. Okay, so we can define difference of two sets A and B. Difference of two sets A and B denoted by A difference B. This is A difference B is given by A difference B is equal to X such that X belongs to A, but, or you can say and, X doesn't belong to set B. Okay. So similarly, if you find B difference A, then X such that X belongs to B, but X doesn't belong to set A. Okay. So that is what difference of two sets. I hope you have understood this difference of two sets. Okay. So let us solve the problems of exercise 1.4. Okay. Let us solve the first question. Find the union of each of the following pairs of sets. So here we are going to find union of these pairs of sets. So set X contains 1, 2, 3, 5, 1, 3 and 5, and Y contains 1, 2 and 3. So union of these two, X union Y, must give 1, 2, 3 and 5. Okay. So we have to write all the elements of X and Y here. Okay. But remember one thing, don't repeat the same element twice, though it is present in both the set. Okay. Similarly here, A union B will give you, here you see A, E, I, O, U, here A, B, C. Okay. So you have to write A, B, C, then E, I, O, U. Okay. This set A union B includes all the elements present in A and B. Okay. Similarly, here you see set A is a set of X such that X is a natural number and multiples of 3. Okay. So X is a multiple of 3. That means here you see natural number multiple of 3. That means it must be equal to 3, 3 to the 6, then 3 3 is a 9, then 12, dot dot dot, so on. Okay. So this set B is X such that X is a natural number less than 6. Okay. It is a natural number less than 6. So it must be 1, 2, 3, 4 and 5. Okay. So if you find the union of these two sets, A union B, then what you will get? So take the elements in both sets. Union of A and B will give 1, 2, 3, 4 and 5. These are the elements of set B. Then we have to take the elements of set A. Okay. So 3 is already included. Okay. Then let's start from 6, 9, 12 and dot dot dot, so on. So that is A union B. Okay. Now next, set A is a set of X such that X is a natural number and X is greater than 1 and less than equal to 6. That must be 1, 2, 3, sorry, here you see it should not contain 1. Okay. So 2, 3, 4, 5 and 6. Okay. It is greater than, sorry, less than equal to 6. That's why 6 should be included. Okay. And next one must be equal to, here you see X is greater than 6, less than 10. So it must be 6 should not be included. Okay. So 7, 8 and 9. Okay. Only these 3. Okay. Less than 10. Yes. So now you see union of these two sets. Okay. Union of these two sets, A union B, will give you 2, 3, 4, 5, 6, then 7, 8 and 9. Okay. Now you see next pair, A contains 1, 2, 3, B is null set. So union of these two must be equal to set A. It is very simple. So we have already got that if A is non-empty set, it is not equal to phi, and B is empty set, it is phi, then in that case A union B always gives what? It always gives A, set A. Okay, so according to that property, this must be equal to set A. Okay, so hope you have understood this. So now let us solve question number 2. So let set A is a set of small letter A and B, then B contains small a, small b, small c. So it is asked that is set A is a subset of B or not. Okay, and also what is A union B. Okay, so now what will be the answer? So set A is what? Is a set of small a and b, and set B contains small a, b and c. So here you see all the elements in set A are in set B. That's why it is obvious that A is a subset of B, and A union B. Here you see, as all the elements in set A present in set B, so A union B must be equal to B. Okay, because these two elements A and B are already in set B, that's why result will be B. Okay, so here it is given. Next question, A and B are two sets such that A is a subset of B, then what will be A union B? So it is obvious, it is very simple question. So its answer will be what? If A is a subset of B, then A union B always gives B. Okay, and remember one thing, if B is a subset of A, if B is a subset of A, if B is a subset of A, then A union B will be A. Okay, so now our answer is A union B is equal to B because A is a subset of B. Okay, so question number 4, it is similar to question number 1. So I have already shown you how to find the union of two sets. So now I will show you one of these three. Okay, so how to find the union of three sets. So I will solve only one from this 7 questions. Okay, so I will show you only one. Okay, so these are very easy questions, so I don't want to waste time solving all those. So let me show you the last one. Okay, so here you see, here set B contains 3, 4, 5, 6, and set C contains here 5, 6, 7, 8, and D contains 7, 8, 9, 10. So B union C union D will contain, first take the elements in set B, 3, 4, 5 and 6, then take the elements in set C. So what are the elements? 5, 6, 7, 8. 6 is already written. Okay, 5 is already written, just starts from 7 and 8 here. Then again take the elements in set B, sorry, in set D. Okay, what are the elements in set D? 7, 8, 9, 10. So 7 and 8 already written, let's take 9 and 10. So 9 and 10. So that's how we can find such. So in question number 5, find the intersection of each pair of sets of question number 1 above. Okay, so here we are going to find the intersection of the pairs of sets which are given in question number 1. Okay, so first pair was here, first pair is set X and Y. Here you see, so how to find the intersection, that is X intersection Y. So here intersection of these two sets means that set of all the common elements of these two. Okay, what are the common elements here? Here you see set X contains 1 and set y contains also 1, and here 3 is also present in x, and in y also 3 is present. Okay, so 1 and 3 are the common elements in these two sets, so x intersection y must be 1 comma 3. Okay, so this is the result. Okay, now let's find the a intersection b. Okay, a intersection b. So let's find the common elements in these two sets. Okay, so here you see set A contains small a, here also a, then only this element a is common in these two sets. Okay, so this is a intersection b. Now set A is a set of x such that x is a natural number and multiple of 3. Natural number multiple of 3, that means 3, 6, 9, 12, so on. Okay, then b is a set of x such that x is a natural number less than 6. Natural number less than 6 are 1, 2, 3, 4 and 5. Okay, so we can take up to 5 as it is less than 6. So here a intersection b. So what are the common elements in these two sets? Okay, so here you can see the common elements are, here it contains 3, here also 3. Okay, these two are common. Then okay, only 3 is common here, so our answer will be set containing 3. Okay, so this is a intersection b. Okay, now next pair is, here you see set A is a set of x such that x is a natural number where x is greater than 1, and less than equal to 6. So that's gonna be equal to, here as it is greater than 1, so it is not equal to 1, so that's why it must be starting from 2, 3, 4, 5 and 6 also included, as there is get less than and equal. Okay, less and equal. Okay, less than and equal to 6. So set B is a set of x such that x is a natural number where x is greater than 6 and less than 10. So 6 and 10, these two are not included, so it must be starting from 7 to 9. Okay, so 7, 8 and 9. Okay, now let's find a intersection b now. Okay, what will be a intersection b? Okay, let's find the common elements here in these two sets. So here you see, so I can't see any common elements here. Okay, that's why result is 5. Okay, sorry, this is 5 means null set. Okay, so if you compare these two sets, you can see there is no common elements. Okay, so in the last one, here you see this is set A and this is set B, so it is null set. Okay, null set or empty set. Okay, so that's why A intersection B will be null set, because there is no elements. Okay, no elements, so that's why there should not be any common element. Intersection B is equal to 5 here. Okay, now let's move on to question number 6. So this is the question number 6. If set A is this, B is this and C is this and this is D, okay, then we need to find those. Here you see, first we need to find A intersection B. Okay, so how to find A intersection B? We need to find the common elements first in these two sets. Okay, so here you see this set A contains 7, B also contains 7, and 9 is also in set A and in B as well. So that's why and one more element, that is 11. Okay, these three elements are common in these two sets, so that's why A intersection B must be a set of 7, 9 and 11. Okay, then let's find B intersection C. Okay, B intersection C. So let's find the common elements in B and C. Okay, so B and C, here you see 11 is common here and 13. Okay, so result should be a set of 11 and 13. Okay, similarly we can find A intersection D. Okay, A intersection C, B intersection D. Okay, I'm not gonna show all those. Okay, now let me show you A intersection C intersection D, how to find this. Okay, so in order to find A intersection C intersection and D, okay, we have to find all the common elements in these three sets. Okay, so what are the common elements in the sets A, C and D, as we are going to find A intersection C intersection D. Okay, so what are the common elements in this tree? Let me check. Okay, here you see in A and D there is no common element, though we have common elements in A and C, but we don't have any common elements in A and D. That's why it is surely empty sets. Okay, in intersection of this tree must be empty set. Okay, empty set. You can write this empty bracket, or you can write phi. Okay, so here you see, so A intersection C intersection D means the set of all the common elements in these three sets. As we have no common elements in set A and D, that's why the result is phi or null set. Okay, so now let me show you this one. A intersection, then whole intersection B intersection C. Okay, B intersection C. First let us find B intersection C here. So we have already got here B intersection C, it is already here. Okay, B intersection C and intersection A, here this is set A and this is B intersection C. Okay, so in order to find this result, we need to find the common elements in set A and B intersection C. Okay, what are the common elements here? You can see here it is 11, here also 11. Okay, only this is the common element, so A intersection whole B intersection C must be a set containing only 11. Okay, this is our result. So that's how we can find this result as well. A intersection whole B union D. Okay, so first we need to find B union D. Okay, let's find B union D first. So B union D. Okay, B union D, it is a set containing all the elements in set D and B. Okay, so here set B contains 7, 9, 11, 13. Okay, and D contains 15 and 17. Okay, write all the elements here: 7, 9, 11, 13, 15 and 17. Okay, now we are going to find the intersection of this and set A. Okay, so now we are going to find the intersection of set A and B union D. Okay, intersection of these two. Okay, so in order to find this, we have to check what are the common elements in set A and in B union D. Okay, So what are the common elements? Here you see it contains 7, and this also contains 7, and B union D contains 9. So set A also contains 9, it contains 11. Okay, it contains 11, and set A also contains 11. So that's why our result is 7, 9, 11. Now we are going to find intersection of A intersection B and B union C. Okay, so we have already got here A intersection B, so we will use this result here. Then let's find B union C from this set A and B. B union C from set B and C. How to find B union C? So let's find B union C first. B union C will be equal to so when you do union, you have to write all the elements in these two sets. Okay, that's 7, 9, 11, 13, and 15. Okay, this is B union C. Okay, this is B union C. So now what we are going to find? We are going to find intersection of A intersection B and B union C. So that means we are going to find the intersection of this set and this. Okay, so in order to find the intersection, here you see what are the common elements. First identify the common elements. Here you see 7, 9, and 11, all the three elements of A intersection B are in B union C, 7, 9, 11. So its result gonna be equal to a set containing 7, 9, and 11. Okay, simply you can say set A intersection B. Okay, so you can write either this set or this result. Okay, because elements in this result A intersection B present in this B union C. That's why we can write the set, or we can write as A intersection B. Now let us find intersection of A union D and B union C. So we already have B union C. We have already done this B union C while we have found the result of question number 9 of question number 6, 9 of 6. So here you see, as we have B union C already, let's find A union D first. Here A union D, that means here A union D will be equal to what? A set containing all the elements in set A and D. So what are the elements here? 3, 5, 7, 9, 11, 15, and 17. Okay, these are the elements present in set A and set D. Okay, so now what we are going to find? Intersection of this set and B union C. Okay, so how to find the intersections? So we have to write the set containing common elements in these two sets. Okay, so that is intersection of these two sets. So how to find the common elements? Here you can see 7, 9, and 11. So it also contains 7, 9, 11, and A union D contains here you see 15. It contains 15. So 15 is in A union C as well. So what we have got here, the common elements are 7, 9, 11, 15. Here also 7, 9, 11, 15, 7, 9, 11, and this is 15. So these are the common elements. So what will be the result of intersection of A union D and B union C? That's gonna be equal to set containing 7, 9, 11, 15, as these elements are common in these two sets, A union D and B union C. So what we have got? 7, 9, 11, and 15. So that's how we can solve. Question number 7. Okay, so here we have set A, B, C and D. 4 sets are given. Then we need to evaluate those. Okay, so let's find. Okay, so here you see set A is a set of X such that X is a natural number. Okay, that means it is a set of 1, 2, 3, 4 ... Okay, and B is a set of X such that X is an even natural number. That means even natural number means 2, 4, 6 ... Okay, even natural numbers. And X such that X is an odd natural number. Okay, that means 1, 3, 5, 7 ... so on. Then D is a set of X such that X is a prime number. Okay, prime number starts from 2, 3, 5, 7, 11 ... Okay, so how to find A intersection B? So intersection means set of common elements. Okay, so A intersection B, what are the set of common elements? Here you see, so in the set of natural numbers, all the even natural numbers are included. Okay, all even natural numbers are included in the set of natural numbers. That's why we can say that B is a subset of A. Okay, if B is a subset of A, that means all the elements in B are in A, then A intersection B must give B. Okay, so it must be B. Okay, now you see A intersection C. Now compare these two sets, set A and C. Okay, so now set A and C. So let me clean this first. Now you can see in these two sets, set A and C. So what you have got in these two sets common. Okay, so here you see this is a set of odd natural numbers. Okay, odd natural numbers. Set C is a set of odd natural numbers, and set A is a set of natural numbers. So that means all the odd natural numbers are in the set of natural numbers. That's why C is also a subset of set A. That's why A intersection C must gives set C. Okay, as all the elements in set C are present in set A. Okay, now A intersection D. Now compare A and D. Now it is a set of set D is a set of prime numbers. Okay, so all the prime numbers are present in set A because set A is a set of natural number. So that's why you can say D is a subset of A. If D is a subset of A, then we can say A intersection D is D. Okay, now let's find B intersection C. Okay, if you compare these two sets B and C, then you can see it is odd natural numbers, and this set B is even natural numbers. So I don't think here you see, so it is obvious that there should not be any common elements. Okay, and so here answer is 5. Okay, because set B is a set of all even natural numbers, and here odd natural numbers. So odd and even cannot be common. So that's why the result of B intersection C is 5. Then let's find the B intersection D. Now compare B and D. Okay, so these are prime numbers and these are even natural numbers. Okay, as you can see that 2 is only even prime. Okay, so that's why 2 is the only common element in these two set A and D. So that's why B and D intersection of these two sets must be set of 2 prime even number. Okay, now let's find C intersection D. Okay, so here you see, if you compare set C and D, you can see all the prime numbers other than 2. Okay, other than 2, all the prime numbers are odd natural numbers. Okay, other than 2, only 2 is even natural number. Okay, other than 2, all the prime numbers are odd natural numbers. That's why we can write C intersection D is a set of X such that X is an odd prime number. Okay, odd prime number. So that is our result. Okay, so let's move on to next question, that is question number 9. So here we need to find difference of sets. Okay, so first here you can see set A is this one, this is set B, and set C and set D. Okay, so let me first show you how to find A difference B. Okay, or you can simply say A minus B. Okay, so what will be the result of this? So A minus B means you have to eliminate all the elements of set B from set A in common. Okay, so what are the common elements in these two sets? Here you see, I can see here 12. Okay, 12, then only 12. Only 12 is the common in these two sets. So let's eliminate this from set A. Okay, so A difference B will be a set which is not containing 12. Okay, it contains other elements of set A. Okay, so that means we have to eliminate the elements from set A which are present in set B. So here 12 is only element which is present in both A and B. Okay, 3, 6, 9, 12 should not be written, 15, 18 and 21. Okay, that's how we can find the difference of two sets, 15, 18 and 21. Okay, this is the result. Then A difference C. Now compare these two sets. Okay, so how to find A difference C? So it's very simple. You have to eliminate the elements of set C from set A. Okay, it's very simple. Okay, first find the common elements in these two sets. Here you see, so what are the common elements in these two sets? 6 is the first common element here, then 8, not 12, then 16 is not there, 14 is not there. Okay, so 12 and 6. So these two elements should be eliminated. Okay, so 3, 9, 15, 18 and 21. So similarly we can find those as well. Okay, I'm not going to show all those. Okay, because the method is same. So now let me show you how to solve question number 10. Here you see there are two sets X and Y. So this is similar to question number 9. Here we need to find X minus Y. Okay, X minus Y, Y minus X. Then so also we need to find X intersection Y. Okay, so as we have done in the question number 7, intersection. Okay, so first let me find X minus Y. How to find it? Just we need to eliminate the elements of Y from the set X. Okay, so what are the common elements in these two sets? B, here is also B, and D, this is D. Okay, so that's why when you find X minus Y, then you have to eliminate these two elements which are present in this set Y. Okay, so A comma C, these are the remaining elements. Okay, then Y minus x, while you find y minus x, then you need to eliminate the elements which are common in both two sets from the set y. Now this is y minus x, so let us eliminate the common elements from set y. Then we will get f and z. Okay, now x intersection y means set of common elements, that is b and d. Okay, now here you see question number 11. R is the set of all natural numbers and q is the set of all rational numbers. Then what is the r minus q? Okay, so you see all the real numbers are not rational. Okay, there are some rational numbers and irrational numbers as well. Then if you subtract the rational numbers, if you eliminate, now when you find r difference q, that means that is a set of x such that x belongs to r but x doesn't belongs to q. Okay, that means you have to eliminate all the elements in q from r which are common in these two sets. Okay, so that's why here you see, so if you eliminate all the rational numbers from the set of real numbers, then you will get irrational numbers set of, so r difference q will be what? Set of all the irrational numbers. So that is the answer of question number 11. Okay. State whether it's all the following statement is true or false. Justify your answer. That means we have to check these statements given here are true or false. Okay, and we have to justify answer. Okay, so here you see these two sets given here are disjoint sets according to these statements. So here you see, as these two sets have common elements, so that is 3 is the common element here, so that's why these are not disjoint sets. Okay, so answer should be false. So it is false because the first set is this and the second set 3, 6. Intersection of these two sets is not equal to 5. It is a set of 3. Okay, it is not equal to 5. These two are not disjoint sets. Okay, so now in the next one, here you see in these two sets you can see clearly a is common element. Okay, so that's why these two are also not disjoint set. Okay, this answer is also false. This statement is also false because intersection of these two sets is equal to 5. Okay, to be disjoint they should not have common element. Okay, but here they have, so that's why they are not disjoint. Okay, here let me write here equal to set of a only. Okay, so here a is the common element, so that's why these are not disjoint sets. Okay, here you see if you compare these two sets there is no common element, so that's why it's true. Okay, here what should be the answer? True. Okay, because intersection of these two sets, okay, gives phi null set because they have no common element. Okay, is equal to 5. In the next one, here you can see these two also have no common elements, so they are disjoint, so it is also true. Because intersection of these two sets is 5. Okay, so this exercise is now completed.